Let's take a look at these examples. Keep in mind that anytime we add BCD code behind 4 bits, we have always decimal digit. So how are we supposed to look at this problem? We have 1, 0, 0, 1. And I have 0, 1, 0, 1. Of course, we talk about BCD, and we're supposed to add these two codes together. Now, this is binary 9, and this is binary 5. Okay, so I have 9 plus 5 is equal 14. So I have 4 and carry of 1. I have 14. Please notice that the answer has 2 digits, 1 and 4, 14. Let's take a look at BCD code right now. We have 1 plus 1, we have 2, right? 0 and carry of 1. 1 plus 0 is equal 1. 0 plus 1 is 1, and 1 plus 0 is 1. Please notice that this is binary 14, but we said that 4 bits of the BCD code represent 1 decimal digit. This is binary 14. 14 has 2 digits. So what we're supposed to do, anytime you get number greater than 9, because in decimal number system, the greatest digit which we use is 9. So when we talk about BCD, we're supposed to have also the greatest number over here, 9. So anytime you get number greater than 9, you're supposed to add 6 to that number. And take a look what will happen. 0 plus 0 gives me 0. 1 plus 1 is 2, right? 0 and carry of 1. And I have 1 plus 1 plus 1 is 3, that's why I have to write 1 and carry of 1. 1 plus 1 is 2, I'm supposed to write 0 and carry of 1. That one has to come down. Now, we have BCD code. BCD code is binary coded decimal. It means that this is 1 digit, and another 4 bits are going to represent another digit of my answer. That's why, because I have 1, I'm supposed to fill up these spaces by zeros. So my answer is 1, 4. So this is 14. 9 plus 5 is equal 14. So this is the solution to my problem. Let's take a look at this example. Again, we have 0, 1, 1, 1, and I have 0, 1, 1, 0. Okay, this is binary 7, and this is binary 6. If you are going to add them up, 7 plus 6 is equal 13. Now let's take a look what we can do over here. 1 plus 0 gives me 1. 1 plus 1 is equal to, right, 0 and carry of 1. 1 plus 1 plus 1 is 3, right, 1 and carry of 1. 1 plus 0 gives me 1. Please notice that our answer is binary 13. But we are not looking for the binary answer. We are looking for the BCD answer. In other words, binary coded decimal. So what we're supposed to do, anytime you get number greater than 9 from your addition, you're supposed to add 6 to that number. That's why I have to add 6. 0, 1, 1, 0. And take a look what will happen. We have 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 2, and carry of 1. 1 plus 1 is 2, 0, and carry of 1. This one will come down. Okay, anytime we talk about the BCD code, we're supposed to have groups of 4 bits. So this is my first group of 4 bits, and I'm supposed to have another 4 bits over here. That's why empty spots I'm going to fill up by zeros. So my final answer is 13. 1 and 3. 13. 13. So that's why this is the solution to my problem. Let's take a look at this example. We have 0, 0, 1, 0 plus 1, 0, 0, 0. I have 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 0 is 0, and 0 plus 1 is 1. This is binary 2, and this is binary 8. 2 plus 8 is equal 10, and this is binary 10. But I'm not looking for binary answer, I'm looking for BCD answer. Again, because my answer has value greater than 9, I'm supposed to add 6. Remember, we have to always add 6. So I have 0, 1, 1, 0. This is binary 6. 0 plus 0 gives me 0. 1 plus 1 gives me 2, write 0 and carry of 1. 1 plus 1 gives me 2, 0 and carry of 1. And I have 1 plus 1 gives me 0 and carry of 1. Again, please keep in mind that we're supposed to express the BCD code in terms of groups of 4 bits. So I have 1, 2, 3, 4 bits, and I have 1 bit over here. I'm supposed to fill up the empty spaces by zeros. And this is 1, and this is 0. So my answer is 0, 0, 0, 1, 0, 0, 0, 0. This is 10. And this is the solution to my problem.